Welcome to The Explainer. Today, we're embarking on a seriously exciting step-by-step quest to build your very own embedded system digital workspace. I know, setting up a new integrated development environment, or IDE, can feel a bit intimidating, especially if you're just starting out as a student. But don't worry, we're in this together. We're going to transform this whole setup process from a daunting chore into a super empowering, straightforward journey. By the end of this, you'll have a perfectly configured KEIL IDE, absolutely ready to write and test your very own assembly code.
Here's the roadmap we're going to conquer today. First, downloading the software. Second, running the installer. Third, creating your first project. Fourth, adding source files. Fifth, configuring target options. And finally, building and debugging code.
Let's kick things off with Level 1, downloading the software. Your very first move is to head over to the KEIL website, specifically their C51 evaluation page. You'll be greeted by a quick form. Just pop in your basic contact info, your first name, last name, and email address. You have to supply this to actually unlock the download. Once you've got that filled out, just hit that submit button to keep moving forward.
Right after you hit submit, you'll want to look closely for a very specific executable file. It's called C51V960AXEX. Knowing that exact file name is crucial so you aren't guessing what to click. Just right-click on that link and save the installer file directly to your computer.
Moving right along to Level 2, running the installer.
Once that file is downloaded, go ahead and double-click the executable. You should be greeted by the KEIL uVision Setup Wizard welcome screen, complete with its classic, kind of retro interface. Seeing this means you are perfectly on track. Just click Next to get the ball rolling.
The very next thing you'll see is the End User License Agreement. To keep our momentum going, just let the wizard know you agree by ticking the checkbox that says, I agree to all the terms of the preceding license agreement. Once you check that box, you can confidently hit Next again.
Now, you'll be prompted to enter your customer information right into the setup wizard. Just type in your first name, last name, company name, and email exactly like you did on the website a minute ago. After filling in those blanks, just follow the default directory prompts to finish up the installation. Once it's completely done, you're going to have a shiny new KEIL uVision 5 icon sitting right on your desktop.
All right, on to Level 3, creating your first project.
So double-click that brand new desktop icon to fire up the KEIL IDE. Our very first major action inside the software is to click Project and then New uVision Project. But hold on, before you save anything, you need to create a dedicated folder. Let's call it something like XP4. Now, the logic behind isolating each lab into its own dedicated folder is absolutely crucial. It keeps your digital workspace totally clean, super organized, and most importantly, it prevents different project files from overwriting or corrupting each other.
To actually start this off, navigate to the top menu bar, click on Project, and from the drop-down, select New uVision Project. Think of this as your primary gateway to starting any new assignment.
Next, navigate inside that newly created XP4 folder we just talked about, and save the actual project file with a matching name. So just name it XP4 right inside that folder. Keeping your project name and the folder name consistent, that is a fantastic habit for any beginner student to lock in early on.
Okay, I really want to pause here for a second because this is a critical step where beginners often stumble. As soon as you save the project, a Select Device for Target window pops up. You have to select the exact microchip target or your code simply won't work. In the search bar, type P89V. This filters the massive list so you can easily find and click on the P89V51RD2 device, which is listed under the NXP vendor. Selecting this specific piece of hardware is literally mandatory for success in this lab. Once you've got it selected, click OK. Oh, and if it asks to copy the startup.a51 file, go ahead and confidently select Yes.
We are cruising. Level 4, adding source files.
When you add a source file, you've got a choice to make, and it all depends on the language you're writing in. The crucial thing to understand here is the file extensions. If you're doing C programming, you'll create a C file that ends in .c. But if you're writing assembly code, which is the main focus of our embedded system setup today, you'll create an ASM file ending in .s. Naming your file with the exact correct extension is how you tell the IDE exactly how to interpret your code.
So here's how you actually inject that new file into your project tree. In the project window, right-click on the folder named Source Group 1. From that menu, select Add New Item to Group Source Group 1. A window pops up letting you choose the file type.
like the C file or ASM file we just talked about. Give your file a name, again, keeping it consistent. Let's call it exp4 with the appropriate .s extension, and then just click Add.
Almost there. Level 5, configuring target options.
To make sure our code will actually run on the microchip we selected earlier, we have to tweak a few specific behind-the-scenes settings. Right-click on Target 1 in your project tree and select Options for Target 1. Or, if you like saving time, you can use the super handy Alt F7 keyboard shortcut to pop open this vital target options menu instantly.
Once that Options menu is open, you need to visit two specific tabs. First, in the Target tab, double-check that your extol, memory model, and code ROM size perfectly match the instructions laid out in your lab manual. Then, and please hear me out, this is incredibly important, switch over to the Output tab. You absolutely must check the box next to Create Hex File. Why? Because this step is what translates your human-readable code into the precise hex format that the physical microchip actually understands. Without checking this box, your hardware literally won't know what to do. After you've checked it, just hit OK.
And finally, the climax. Level 6, building and debugging code.
With your code written and your options completely set, hit the F7 key or click the Build Target icon. Now, keep your eyes on the Build Output window at the bottom. What you are looking for is that glorious, beautiful message that reads 0 errors. Getting 0 errors is basically your visual reward for a perfect software setup. It means your IDE has successfully compiled your project and created that crucial hex file we just talked about.
Finally, click the Debug icon to enter debug mode. This lets you peek right under the hood of your processor. In this view, you can open the Registers and Memory tabs to see real-time data flowing. If you hit the F11 key, you can actually step through your code line by line, watching exactly how the register values change in real time with every single instruction you've written. It's like watching the Matrix. And if you ever want to start over, just click the RST or Reset icon to run your code from the very beginning.
Just look at what you've accomplished today. You've navigated the installation, meticulously configured all those project settings, and successfully entered the debugging environment. Your KEIL IDE is fully set up, and you've totally eliminated all those initial configuration hurdles. This software is absolutely your new superpower for embedded systems. So the only question left for you is, now that your environment is ready to go, what is your very first assembly program going to do? Get out there, start coding, and I'll catch you in the next explainer.